Welcome. This is State of Affairs, a series, hopefully a series, where we explore topics that you should probably have an opinion about so that you can form an opinion about it. I want to explain how the stuff works and where the contention is. You know, the dynamics of the situation, who the players are, and what they're up to. With any luck, it'll be helpful towards understanding which aspects of the problem you can personally relate to and value, so that you can create an individualized stance and uniquely contribute to the greater conversation. So to form an opinion, I usually like to think that we ought to be on the same page at least on what specifically we're talking about. Lots of times we might just be loosely familiar with the buzzwords and can't really follow what a specific narrative is trying to say. I would like to first talk about the ground truths to artificial intelligence and then move into the ins and outs of OpenAI's new ChatGPT, if you've heard of it. If not, that's okay. It all gets expertly explained in a impactful for all kind of way. We must fully understand all there is to know to hold a position on what should be decided. The rough idea is probably good enough. So let's get through the crashest crash course to ever course for crash on artificial intelligence. When someone says artificial intelligence, what are they really talking about? After 3 to 4 Googles, you get something like artificial intelligence or AI as anything that can do a task that resembles human intelligence in some way. Simple enough, but honestly, it feels like a misrepresented pair of words because human intelligence on its own doesn't really have a defined meaning from a philosophical standpoint. So slapping this artificial tag on it doesn't really help us. But to get a clue of what we're talking about, we might need to do a little bit of a story time. You see, the first versions of AI looked kind of like one of those choose your own adventure books, but like with a keyboard. It was programmed to have a lot of different branching options that would end up at one of many different conclusions. This process of a bunch of different options leading to a bunch of different conclusions would progress using a series of conditional checks and basic logic stuff. If you take an example like The Cave of Time, a true classic in the choose your own adventure books, it could arguably be considered artificial intelligence if it's run with an algorithm or a program to do it. You got all these branching options and it evidently reacts to its environment, which are just what your choices are, and then boom, it's doing stuff, it's smart, it's making decisions, and it's basically thinking just like some people do. There's no reason why this wouldn't fall under artificial intelligence, even though it is a little bit underwhelming. The expert systems that were initially created were hard-coded to respond to select prompts and select types of answers. As you might have guessed, early AI doesn't really count as intelligence anymore. In reality, the mystery of intelligence will continue to be a moving target, as was nicely predicted by expert systems expert Ware Myers in 1986. So let's get with the times. What's in now is still these branching options and actions, but now the trick is we don't have to program the AI to some specific end explicitly. Instead of basic logic to implement solutions, we use advanced statistical analysis. This is the realm of machine learning, or ML for short. If we aren't caring about our expert systems anymore, machine learning and artificial intelligence are pretty interchangeable to use. ML is technically a subsector of artificial intelligence though, so an intelligent system might use several machine learning techniques and procedures within it. But back to the statistics. I won't bore you with the specific techniques people use because there's like a billion sneaky math things that these nerds figure out, but machine learning relies on a few things. You have a process of taking an input set of random data, and then you categorize them and label them into nice rows of numbers, and then you do some kind of statistical acrobatics to isolate key features. A well-explained and excellently animated example of one of these magic tricks is this video on convolution. I wish I was better at visual aids, but for now you get figure 1. Observe how messy shapes become an ordered line of shapes. or even a pattern, some have said. We're basically just sorting information according to shapes, metrics, or features. The algorithm learns by calculating just how similar objects are to one another, and then finds the best way to model and represent their similarities. And then when it has these patterns lined up, it takes a new input, maybe a query perhaps, and it tells you how that new thing fits into the patterns that it's created and sorted real nice. You know, it's like weather people. They look for weather patterns so that they can forecast what's next. Those weather people are viewing climate as a predictable sequence. What has happened in the past will continue a trend into the future. For some machine learning, it's a sequence like this, but for others, it's more like a classification. Object recognition in applications of things like image processing and computer vision works more like the thought process of, well, if it looks like a duck, and it looks like this other duck, and it looks a little bit like this other different duck, then by golly, it must be a duck. And boom duck, the AI learned to classify and identify what a duck is. Both methods deal with recognizing correlated features from a data set and then extrapolating from that sorted data. So this is the level of intelligence that we're currently working with. Machine learning takes an input, finds a pattern within that input, and then makes a guess at how other stuff fits and interacts with that pattern. I mean, technically, if we're believers in the intelligence quotient, this is exactly what IQ tests for. Take these tiles, find a pattern within them, and then see which other stuff resembles what's missing in the pattern. And this seems to loosely resemble how we view human intelligence. So that's pretty good. What I'm really trying to focus towards is that OpenAI's hench tools don't really think in a different way than what I've described. It's all just this statistical version of the same choose your own adventure books that we've seen since the beginning. And I think the usual difficulty that you see in this topic is that there's not really an accessible way that I've seen to pierce through the armor that is the fantastical complexity that is artificial intelligence. I think there are some really interesting ethical nuggets that we can discuss that are kind of stuck behind these conceptual walls of papers talking about factorized embedded parameterization. But before I get lost in my own sauce, let's get to the fun part of the video. OpenAI is the hot topic, and ChatGPT is its greatest champion. A quick rundown for you. It takes the beginning of a sequence, a normal prompt or query that the user inputs into the algorithm, and generates how that sequence is most likely to continue. The sequence obviously looks very similar to a normal question and answer sequence. You might ask, how do bagels work? And then it answers how bagels work. In like a normal conversational and natural way, not like how I would probably do conversations. It is generating a forecast for how a conversation would most likely continue based on the prior underlying patterns that it has calculated. Just like how weather people might forecast how a storm would naturally continue. It analyzes all sorts of common text and data and finds patterns within language itself, trying to isolate what the most relevant parts of a word are in specific contexts. So it's really just statistically finding the most likely next word or sentence or paragraph. In a highly advanced and technical conversation, an extremely smart individual might liken this process to a fancier but less robust Google. Don't do that. People will yell at you. I've heard. The main progress is not to compete in the informational benefits that something like a Google has, but it's to showcase its efficiency in producing natural sounding language. The strength of the tool is its ability to generate coherent thoughts much faster than normal people can even think. What it can't do is provide verifiably accurate information on any given topic, since it's only really following what some underlying statistically likely speech pattern would exist in a general case. Why this dynamic exists of words sounding good but might not actually be good is the result of reinforcement learning. What I have covered in machine learning is the ability to detect and continue patterns. Reinforcement learning is where the algorithm spits out the prediction as normal using its patterns, and then some kind of reward system is in place to undermine or support the solution that it is given. If the action is deemed good by the reward system, then the algorithm remembers to output similar actions more often and less otherwise. Reinforcement learning is super hot and cool and attractive right now because it's the closest thing to being like actual intelligence. A system can essentially generate something on its own and then learn from feedback to continually improve, similar to trial and error and more conventional learning behaviors. Reinforcement learning is still a very tricky balance to strike though, because it still relies on a very robust reward function. And if done incorrectly, you can begin to reward unwanted actions. Rewards can sometimes motivate short-sighted behavior, making an algorithm seem greedy and focus on doing a few promising actions, but then overall remaining static. Inversely, the reward system might not motivate anything at all, and the algorithm spends a lot of time wasting resources pursuing side tasks that aren't ever going to contribute to an optimal solution. Tweaking these so-called exploitation versus exploration parameters is hard to perfect. And even if you get this perfectly correct, you still run the risk of having a reward function that does not actually reflect what the desired outcomes are. In cases where the objective is hard to really pin down, like having, I don't know, a subjective reflection of what sounds natural in human language, it might take thousands of iterations before you get to the right one, the right reward function, which motivates correct behavior. This process is painstaking and extremely selective to the specific outcome that you want, meaning your rewards balance won't transfer easily into other domains, kind of like at GameStop. I like this blog post on reinforcement learning where the author likens the process to a demon that's deliberately misinterpreting your reward. You can see on ChatGPT's main page that they use a reward system that is kind of like its own machine learning process, with the objective of representing a model for how a human might subjectively reward the greater ChatGPT generation. It predicts how humans will measure the sampled solution. This means that the reward function falls directly into Goodhart's trap. When a measure becomes a target, it ceases to be a good measure. The reward system has the objective of representing human measurement abilities. This undermines the subjective measurement nature of the human grader because there's no grounded reference point to point to. OpenAI acknowledges this as an overoptimization of the reward function, which contributes to this information accuracy problem that they seem to have. When you're overfitting a reward using a system that doesn't know what true facts are, then your training will resemble natural language for the general case, but not accuracy for the specific cases. This makes the prediction aspect of things prone to misinformation, as it has no capacity to sort or filter what verifiable information looks like. Okay, all right, okay. So who cares? What do we get from this? We get a couple things. The main pieces are that for natural processing, this tool, ChatGPT, is an absolute beast. The scale is quite profound and lends itself easily to development and fine-tuning in the future. And because of the dynamic between coherence and accuracy, people have said that it's great for generating filler or doing the grunt work that you don't feel like doing, or maybe it takes too long to generate original ideas on your own. All you have to do then is replace the slight inaccuracies with some of your own conceptually compelling thoughts. In this way, it looks like a great assistive tool rather than a replacement one. Hey, so that was the end of the video. Hope you liked it. Actually, it got a little bit long, so I decided to split it into two parts. So you can go check out part 2, and that's more going to talk about the discussions and different perspectives on ChatGPT and large language models as a whole. This video more covered the conceptual development of artificial intelligence and kind of where the state of the project or the field is now. but that will cover more, like academic papers and, news perspectives and, different ideas that are looking at the concepts rather than exploring the concepts themselves. So if you want to get behind what all the hubbub is about, I would recommend going over to that one after you collected your brain and kind of consolidated. Maybe take a nap. I don't know, but I hope to see you in the second one. Okay, thanks. Bye.